This is lesson 3.1, part B of the lesson, the second video, and we are starting on page 126. And we're just going to do a little bit of work with algebra tiles. I'm not going to test you on anything with algebra tiles, but it can be really helpful for understanding what's going on. So I strongly encourage you to do the practice work, or at least make sure you understand it. Okay, so in this book, shaded is positive, unshaded is negative, and a little square is 1. The idea here is that this is 1 unit in this direction and it's 1 unit in this direction, so the area of this square is 1. And then the X tile is 1 unit across here and X units going up and down. Really important to know that you can also write it sideways. It is the same. It's the same thing if it's sideways. It just fit better for whatever reason to put it sideways. And it's 1 unit wide and X units long. And so it has an area of X. And then our big square is X units in one dimension and 1 X units in the other. So the area of this is going to be X squared. Okay, so that's how the tiles work. State the polynomial expression which describes each diagram. I want to be really clear. It's the simplified one that we're looking for. Okay. So for this, the first one, this is going to be negative X squared and 2 X tiles and 1 unit tile. Okay. For example B, we're going to cancel some things out because if I have a minus X and a plus X, those cancel each other out. A minus 1 and a plus 1 cancel, and a minus 1 and a plus 1 cancel. So what we're left with here is 2x squareds and a negative 1, or we would usually write that as 2x squared minus 1. This first way of writing it's not wrong. It's just not the way we normally do this. Now, after what I said about algebra tiles, I'm actually going to skip the adding and subtracting using algebra tiles. Because this is review, I don't think it's particularly useful here. So let's just add these using just algebra, okay? So just to remind you, when you are adding two polynomials, you think about it as I'm just tossing it all in the basket. So I can just rewrite this.
Sorry for the interruption. Grade 9 students, last name M through F, wishing to have motorway tags, please head to the theater. That's grade 9 students, last name M through F, wishing to have retakes, please head to the theater.
When you're setting up a question like this, if it's a word problem, I really recommend that you write it with the brackets around it because it makes it like the 2x squared plus 1, that came from somewhere. And so if you put it in brackets in your question, it's it's easier to find where that came from because then you're looking for 2x plus 1. You're not looking for a 2x squared somewhere and a 1 somewhere else. You know that those come together from something. And the same with this. But when we're adding them, we just drop all the brackets and then we can group our like terms. So I'm going to put a 2x squared here. And a strategy that I use is I underline it as I use it. So I'm going to put my 2x squared there, and then I'm going to underline this. I'm going to add my x squared. Notice that I included the plus sign in what I was collecting there. And then I'm going to do this in a different color just because it's easy. So this is minus 2x. That's the only x terms that I have. And then I have a plus 1 and a minus 3. And so because of the way I've done this, I can, by doing the underlining things, I can see that I've got them all. I've used them all up. I haven't missed anything, and that's really useful. If you cross it out, then if you missed one, if you made a mistake and you have to go back and you erase it, sometimes it's not there very much. When you erase it, it fades or whatever. So this is a strategy that I find really useful. And then I'm going to add my like terms. So now I've got 2x squared plus an x squared. That's 3x squared. I only have the minus 2x. And then I have plus 1 minus 3. That's going to be minus 2. So this is my answer here. Okay. Now to be clear on this is optional. And this is also optional, okay? If you are good at this and you are getting these right all the time and you can do this in your head, go ahead and do it in your head as long as you're going to get it right 100% of the time. You can do that, okay? Now, let's talk about subtracting. When we subtract polynomials, we can't subtract something. We're taking away. Let's just make this talk this. We're taking away 2x and we're taking away -5. So the best way to think about this is that I'm going to change the sign of everything in the bracket. So I'm going to keep the 4x plus 3 because I'm adding it, right? I can think about this as I've got 0 and then I've got that added to it, okay? We don't ever write that part, but you can think about it that way. And then instead of subtracting that, I'm going to add the opposite. So instead of adding 2x, or instead of having a positive 2x, I'm going to have a negative 2x. And instead of -5, I'm going to have +5. Okay, that's what's written over here. It's just clearer if you write it below. So we're going to do this here. Now, when you're doing this, please don't skip this step where you lose the brackets, okay? So I've got -x² plus 3x minus 2. And then I can write it this way. Let's go ahead and do that. So I'm going to make this plus. Here, let's do this one. So that's plus -2x² plus x plus 1. So I've changed the sign of everything in the brackets and made it a plus. Most people, once they've been doing this for a while, don't write that line. The line that you must always write, you cannot skip this one, is the one where you drop the brackets. So I'm actually going to go directly from this line to here. So this is going to be -x² plus 3x minus 2 because I'm not changing anything in there. And then I have -2x² plus x plus 1. So you can see that I got the same thing as I did here if I were to drop these brackets. You can also, another way to think about this is that this is what's the coefficient of this term? Well, it's -1, right? There's a little invisible 1 there. So I'm actually multiplying this times -1, and I'm multiplying that times -1, and I'm multiplying that times -1. So that's where I get my -2x² plus x plus 1, okay? This line right here is not optional, okay? I know people in third-year university is studying engineering, and they do not skip that line. So do you really think you're better at math than somebody who's in third-year engineering? I mean, you may when you get there, but are you right now? Probably not. So let's not skip that line. This one you can skip if you want to. This one is not optional. This next one is optional, but it's helpful, especially if you've got a whole bunch of things that you're adding and subtracting, you've got a big long line of them and you want to make sure you don't miss any of them, okay? So I've got a -x² and a -2x². And then I'm going to change colors. And I've got a plus 3x and a plus x and a -2 and a plus 1. And now I can actually do my adding. This is going to be -3x² plus 4x minus 1. And there's my simplified result of the addition, okay? Anytime you're asked to add this or combine like terms or whatever the instructions are, you're always going to simplify it, okay? This line here, this is not the answer. This line here is not the answer. Simplified is always implied there. All right. When we talk about like terms, I've already mentioned it, I guess. Like terms have the same variable to the same exponent. The coefficient doesn't matter. Coefficient does not matter. Just the variables and the exponents. So These all have just an a to the invisible 1. Those are like terms. These all have x cubed and no other variables. Those are like terms. These are examples of unlike terms. They've all got x's, but they've got different variables. These ones have the same coefficient, same exponent on the variables, but the variables are different. So those are unlike terms. And so when we're combining, when we're doing this algebraically, we combine like terms to make a single term. So let me do an example of how I might do this if I didn't feel like rewriting it out, because as you get better at these things, you get shortcuts come in. Okay, I still think that underlining things is worth doing because it doesn't take any time at all. So I'm adding, so I can just imagine the brackets are dropped. I don't need to do anything special there. And I've got 3a minus 3a. That's just 0a. So I don't actually need to write anything. And then I've got minus 4b. Oh, I'll do this in a different color. I've got minus 4b plus 3b. That's going to be minus b. And then I've got c minus 5c. So that's going to be minus 4c. So there's my answer. Okay. When you are confident that you can get this right all the time, you can do it that way. I do still recommend underlining as you go. Just make sure you don't miss anything. Okay. Now this is doing subtraction by stacking them, and this is definitely a way that you can do this. When you do this, always make sure that you put brackets around this the bottom one, and you put the minus out to the side because you have to think about that every step of the way. So what I have here is I have 4x squared minus 2x squared. That leaves me with 2x squared. And then I have minus 9x minus negative 3x, which means that's minus 9x plus 3x. So that's minus 6x. And then I have 6 minus negative 1. That is 6 plus 1. So that's plus 7. Okay, that's how you do that when it's stacked. If you're stacking for addition, you don't have to worry about the minus out to the side. I think this is risky. I don't typically do it that way, but it's a good strategy to have. Okay, and now we're going to simplify these ones. These are already just terms or polynomials. We're just going to collect them. So I'm going to do my shortcut again. I've got minus 2x squared minus 6x squared. That is minus 8x squared. And then 4x minus x is plus 3x. And plus 3 plus 5 is plus 8. Now to be clear, I don't teach this way when I do grade 9 because grade 9s are learning to identify like terms, and there's more steps involved when you're learning. Now actually this is an example of where I probably wouldn't I wouldn't use the shortcut on this because there's too much going on. They all have A, B, and they've got different exponents, and that just is confusing. So I'm going to start with my highest. It doesn't actually matter, but because I want it sorted at the end by the A's, the degrees on the A's, I'm going to start with this one. That's the highest degree of a term with A that I have, so I'm going to write that. That's 4A cubed B. And that's the only one with A cubed B. So now I'm going to look for A squared B. So this is plus A squared B. That's different. That's different. This one is A squared B. So plus 5A squared B. And then I've got minus AB squared. And then minus 7AB squared. And another idea, if I have lots of terms and I'm doing this, I just count them. I started off with 1, 2, 3, 4, 5 terms, and I have 1, 2, 3, 4, 5 terms. That means I got them all. Sometimes things get messy and I miss terms, and so do you. So just pay attention to that. Okay, now I'm going to combine my like terms. And now I can see that I only have the one with the a cubed. So this is 4a cubed b. And because now these are sorted, I can make sure these actually are the same. I've got a squared b. So I've got 1 plus 5. That is 6a squared b. And down here, these are both ab squared. Minus 1 minus 7, that's minus 8ab squared. Okay, this is harder to do when they all look kind of similar. Okay, that is the end of this lesson. Go and do the practice work. Make sure you mark it, please. It's really easy to make mistakes in this, and you want to know what kind of mistakes you make. Bye.